This is problem number, I think it's 58. Yeah. Problem number 58, and this is going to be like a really, really good one, so make sure that you understand this one very well. We've got this water here, comes down, and comes over, and this right here is our ground. This is 9 foot, 6 foot here on our gate. Okay, this is going to be point B, this is going to be point A, and this angle is 60 degrees. Okay, we have everything we need now. We are asked to find reactions A and B. B equals pin. A equals a roller. So that means the diagram here is going to look a little bit like this so far. And we're given that the weight of the gate is 800 pounds and the width at width 2 foot. Okay. Solution. There's a few things you need to know. I'll write them at the top right here really quick. For a hydrostatic problem, you're going to need to find just poked right through the paper, Fr, which is going to be equal to gamma h bar A. And you're going to need to know Yp and Xp. It's going to be Y bar plus, usually it's going to be this, it's going to be Ix, but in most cases you can just remember it as 1/12 B, little b actually, A cubed over Y bar A. And for this one, it's going to be X bar plus 1/12 B A cubed Y bar again A. That's right here where a lot of confusion happens. If you're doing XP, it's X bar here and it's Y bar. When you're doing Y bar, it's Y bar here. It's still Y bar. This portion doesn't change on either. It's only this that makes it X bar or Y bar. Okay, so those are the three basic equations you're going to need to know. So with these, let's get what Fr equals. What's the gamma of water in the imperial system? It's going to be 62.4 pound per foot cubed times 32.2. What is this going to be? Pound per second squared. What am I doing? H bar. What's H bar? We've got a triangle here. 6 foot. And to get these two, we can get 6 sine 60. This is going to be 5.19 foot and 6 cosine 60. It's going to be 3 foot right here. So forget I did gravity. That doesn't make any sense because we're doing FR. Gamma H bar A. So what's H bar here? Well, it's going to be half of this. So it's going to be 5.19 divided by 2. It's going to be 2.59 times the area, which right here, 2 foot width, 6 foot length, 6 times 2 times 12. 62.4 times 2, well actually I can use those, times 12. I'm getting not entirely correct. I know why, because it's here. 9 plus this. H bar from the surface. Actually, this is going to be 62.4 plus, or times 9 plus this times our 12. Here we go, 86, 84 pound. Remember, this is in feet and this is in feet squared. So we have feet cubed times feet squared. These cancel out and we're left with just pound. All right. Now that we have FR, we need to find YP and XP. And these will be useful because our force resultant is going to be acting along the, I don't want to mess this up. One of them is going to be center of gravity. The other is going to be center of pressure. I believe, yes, FR acts at the center of pressure. And then weight would act at the center of gravity, if I'm not mistaken. Now remember, these are two different points. Center of gravity and center of pressure are not always at the same spot. So now that we know this, what's our y bar going to be? Well, it's going to be our 2.59 right here. So 2.59 plus our 1/12. What's our a going to be? I believe this is going to be B. This is going to be A. This is going to be 3, 6 cubed over 2.59, 6 times 2. That's our area. .32 feet. And now let's do X bar. This is going to be 1.5. So we're just going to come up here. Make this 1.5. It's going to be 1.5 plus 1/12, 3, 6 cubed, 2.59, 6 times 2. And that's going to equal 3.23 feet. Now we have our FR, our Y bar, our YP, and XP. This is our diagram right here. So we know what our W is. We just found FR. We know this distance, and we know this distance. The only thing we don't know is AY, so I think a good starting point would be to take the moments about B and find A. And then from there, we could do the sum of the forces in either direction to get X or Y. And yeah, that's pretty much it. Start with one moment and then do two forces, and we'll be done with this problem. And this is going to be how to do your basic hydrostatic problem on a flat plane. So let's start now. Sum of the moments about B. So we're going to go from here. It's going to be our 800 pound. It's going to be R cross F. So really we could do it the other way. So our distance here is going to be probably 3 divided by 2. So it's going to be 1.5 times 800. Or this is R cross F. And we need to say, is this positive or negative? I think we want AY to be positive, so we'll take this as being negative. We indicate that here. And now we're going to be subtracting, because FR is going down. This is going to be our .23. And this is going to be times, I'm assuming this is going to be sine 60. Or actually, it's not. It's just normally it's our pounds right here. 8684. And this is going to equal, so this is going to be plus 3 AY. So if we make this positive and then divide this by 3, our AY should equal 1.5 times 800, 3.23 times 8684. Add these together, divide them by 3. AY is going to equal 9749 pound. Now let's do sum of the forces in the Y. So here we have 9749 minus 8684 cosine 60 minus 800 plus by. So let's do this really quick. Flip these signs. So this is going to be subtracted. These are added. So it's going to be 8684 cosine 60 plus 800 minus 9749. That's divided. Whoops. And I'm getting by equals 4607 pound, and sum of the forces in the X, we're going to have FR, this is just going to be FR sine, this is going to be 8684 sine 60. That's it. It's going to be FR sine 60 minus BX. So therefore BX equals 7520 pound. Now it would make sense to make this kips, so all we're going to do is divide each of these by 1,000. AY equals BY equals BX equals, this is going to be 9.7 kip, 4.6 kip, and 7.5 kip. And there you go. That's how you solve this problem. Actually, whatever. About 9.8. I think the book wants 9.8 for that one, but the rest are alright.